Hello everyone, I'm Nagarasan Ramesh from University Malaysia Pahang, UMP Malaysia. Today I'd like to present about my paper which is Kinetic Studies of Oil Extraction from Microalgae Chlorella vulgaris, Free Cell Culture and Immobilized Microalgae. Basically, global environmental challenges and depletion of fossil fuels have triggered the demand of renewable energy. The utilization of microalgae has emerged as a promising feedstock for biodiesel production. One of the algae's most prominent characteristics is it absorbs carbon dioxide for growth, thus reducing the greenhouse effect. Moreover, microalgae do not require a large area for development compared to other crops, have a rapid growth rate, and also grows well in various salinity levels. The main limitation of microalgae biomass is the high cost of production. The high cost due to harvesting and separation of biomass, which may represent up to 20 to 30% of total production cost. Therefore, selecting a suitable method for separation of biomass is crucial from the economic perspective. Recently, immobilization techniques have become a promising alternative due to their simplicity and cost efficient compared to conventional methods such as centrifugation, filtration, and flotation. It is also necessary to choose an efficient oil extraction method for microalgae because of their small cell size, thick rigid cell wall, and also complex cell membrane. Besides, the selection of efficient lipid extraction solvents are also crucial for ease of operation and scaling up for industrial application. Several factors are considered such as low cost, non-toxic, high efficiency, low boiling point when choosing a suitable solvent. Considering these factors, heptane can be a good solvent for oil extraction from microalgae, replacing hexane, chloroform, and methanol. However, the oil extraction from microalgae is still not established well industrially. To overcome the issue, kinetic studies is vital as it enhances the understanding of process nature and reveals the feasibility of the process and also the raw material. Therefore, this research aims to study the effect of different solvent systems for oil extraction from free cell culture of Chlorella vulgaris and also determine the kinetic values and compare between the free cell culture and also immobilized microalgae cells of Chlorella vulgaris. The novel approach of this research is introduction and investigation of immobilized technique for separation of microalgae in terms of oil extraction. For the methodology, we started with preparation of growth medium, then we continue with cultivation of free cell culture with 14 days of aeration, then we harvest the free cell culture using centrifugation method, then we extract the oil from free cell culture using three different solvent systems, which is heptane, heptane methanol, and heptane ethanol systems. Then we calculated the yield of oil extraction, reaction rate constant, and activation energy. Comparing the values, we choose the best solvent according to the kinetic values. Then we started to prepare the immobilized beads of microalgae, harvesting it using simple filtration method. Then we again do the oil extraction using the solvent selected as step 6. Then we calculate the yield of oil extraction and kinetic values and compare with the free cell culture. For the results and discussion, we have separated into several sections. The first section discusses about effect of different solvent system on extraction kinetics. Highest percentage is achieved at the highest extracting temperature and also longest mixing time. Heptane ethanol system yields the highest, while heptane alone yields the lowest oil. This might be due to the polarity of solvents and the capacity of solvents when it mixed with the other solvents. And over here, comparing the kinetic values, heptane is chosen as the suitable solvent system since it has the highest value of reaction rate constant as follows. Then another positive note of heptane is it is less toxic than hexane, which is a common solvent for oil extraction. Heptane is chosen from the previous section and also used for extracting oil from immobilized microalgae. The highest oil yield extraction achieved at the highest temperature and also longest extraction time, which is 39.12%. Then the kinetic values of the extraction process is calculated and compared with the free cell culture. Free cell culture has the largest reaction rate constant, thus making it more suitable and also feasible for the extraction process. Then the third section is calculation of activation energy. Activation energy here is defined as energy needed to convert the kinetic energy to potential energy for every reacting material mole. The values of activation energy for heptane, heptane methanol, and also heptane ethanol system are shown in the slides. Then the activation energy for oil extraction from immobilized cells yields up to 200 kJ per mole, which is higher, way more higher than the free cell culture systems. Then the oil extraction occur more accessible for free cell culture compared to immobilized cell cell culture. Lastly, we have calculated the overall cost. The cost for the current context was estimated by calculating the total solvent used and also cost of harvesting the both microalgae cells of Chlorella vulgaris. The total cost for extraction of oil using free and immobilized microalgae cell was approximately 67 USD and 66 USD respectively for heptane solvent system. Therefore, it can be said that solvent extraction using heptane for both free and immobilized microalgae cells of Chlorella vulgaris is economically attractive, industrially viable given the less environmentally damaging properties. And compared with the separation technique, immobilized microalgae has been lower cost lower compared to the free cell culture. So, to make the immobilization process more feasible, there should be a further investigation on immobilization technique. As for the conclusion, the kinetic study showed that heptane had a higher reaction rate constant than ipton-methanol heptane ethanol systems. As a result, heptane is selected as a solvent to extract oil from immobilized Chlorella vulgaris. Heptane oil extraction of free cell culture yields the highest K value than the lowest activation energy when compared to immobilized microalgae cell. So this study's finding hypothesized that heptane is an environmentally friendly replacement for extracting oil from free cell culture of Chlorella vulgaris microalgae. And also at the same time, there should be a further investigation needed for the immobilization technique to become more feasible in future. We, we would like to acknowledge and would like to thank University Malaysia Pahang UMP for providing financial support to complete the current research study under UMP Fundamental Research Grant and also UMP Postgraduate Research Grant Scheme. So here is the previous studies we have referred for the current research study, and that's all from me. Thank you. If you have any question, feel free to ask or feel free to email me through this mentioned email address. Thank you.